So, welcome to the last episode for the present value series. And now, before we start this video, I have told you in the past episodes that we are to discuss these topics, right? But I'm going to add one here. I'm going to add other twists. So, where are we in these topics? So, as I have remembered, we're already finished with the regular terms of debt agreements, and we are already finished also with the effective interest rate and the interpolation, right? So, we should put smileys on them. And so, we are to finish these two in this episode. So let's start this video lecture after this short intro. So let's begin with the getting of the present value of debts where you need to pay multiple non-uniform payments. And in order for you to relate immediately, let's have an example, okay? So the sample problem goes like this. You will be borrowing some money today. And the creditor told you about the payment terms already. But the proceeds that you are to receive yet is still a surprise. So, the payment terms are, number one, you need to pay at the end of year 1, 400,000, and at the end of year 2, 300,000, and at the end of year 3, finally, you are going to pay 200,000. So, that's a total of 900,000 worth of future payments. So here, as you can see, the payments that you are to make in the future is multiple, but they are not uniform. Okay? So let's continue. And aside from that, the creditor told you that they have already imputed 10% interest on the scheduled payments, meaning these three payments here have already been added with interest. So if you analyze deeper, then you should not expect that you will get the whole 900,000 as proceeds. Expect that the proceeds that you will receive will be lesser. Now, if you are to receive the proceeds later this day, how much do you think will you receive later? Or stated differently, what is the present value of your debt today? So, there are two ways to answer this. So we have solution number one, which uses the timeline, and the second one, which uses the future payment times the present value factor. So let's have the timeline first. So this is the timeline, and these are the scheduled future payments of 400,000. The other one is 300,000, and the other one is 200,000. So the amount here is what we're looking for. Okay? Now, even if we don't know this amount yet, we know that this unknown amount will increase by 100% plus the interest rate of 10% per year. And that is based here in this example, right? So, let's multiply this unknown amount by 1.10 in 2 years. Okay? So, to get this present value here, let's work back. So we have done this so many times before. So I know that you are very much familiar with this one. So this must be 200,000 here. If this is 0. Now, let's divide it by 1.10. And we will get 181,818 plus 300,000. So this must be 481,818. And then divided by 1.10 again, and we will get 438,016. And since, as if this is the balance after you paid 400,000, then this amount here must be 838,016. And divide it by 1.10 for the last time, and we will have the present value that we're looking for, which is 761,833. So, in conclusion, expect that the proceeds that will be released to you will only be this one and not the whole 900,000. Now, The twist that needs to be highlighted is not found in this first solution, but on this second solution, which uses again the present value factor in calculating. And the twist is you need to treat each of these payments as separate debts and use the present value of one factor because the PV ordinary annuity factor and the PV annuity due factor, those are only good for multiple uniform payments. Okay? So I hope you remember that. So the payment that will due at the end of year 1 is 400,000. So we need to multiply it with 1 plus I raised to the power of negative n, or 1.10 raised to the power of negative 1 only. So the n is negative 1 only because from now or this date, it will become due only after 1 year. So again, n is negative 1. So if 400,000 times this, and if you're going to calculate this, you will get 363,636. So you can check that on your own if you want to. So let's go to the second payment. So the second payment is 300,000. It will now be multiplied with 1.10 raised to the power of negative 2 already, because it will become due after 2 years from this date here. And if we calculate this, we're going to get 247,934. And of course, moving forward, we have the last payment of 200,000, which should be multiplied by 1.10 raised to the power of negative 3. Okay? And if we do that, we will get 150,268. Now, if we add these three present values that we got, then we will have 761,838. So there is a discrepancy of 5 when compared to here. It's because of rounding off. And it's really immaterial, so we don't have to worry about it. So to summarize, if there are multiple but non-uniform payments, we need to get the present value of the debt or receivable by treating each payment as separate debts, just like what we did here. And with that, let's put a smiley here. And now let's talk about the other twists after this. So actually, there are only two other twists that I need to explain. So the first one is, what if the present value amount is given, the maturity term is also given, and the effective interest rate is also given, but the future payment amounts is missing? So how will we find that? So let's go back here and let's focus on this 400,000 first payment. Okay? So what we did here is find the present value of this 400,000 here in this date or before 1 year. And the answer is 363,636, right? Now, what if it's reversed? What if this 363,636 is given and the 400,000 is not? It's easy, right? You can just work back, like 363,636 divided by this factor, and you will get already the 400,000. So the factor here is never a problem because you can get that if the effective rate and the maturity term is present, right? So that's how easy the twist number 1 is. You just have to work back. So now let's go to twist number 2. And let's answer the question, what if the debt is compounded in periods less than 1 year? Okay? So for you to relate immediately, let's go to a sample problem. So the sample problem is as if you made a borrowing today. And because of that, you are obliged to pay 2 million at the end of 2 years. So, the interest of 10% per annum was already imputed by the creditor on the scheduled payment of 2 million. So, pause. Let me add something here before we continue. Guys, if you see a rate in a problem, please treat it as an annual rate or rate per year if the problem is silent, okay? Now, let's continue. Aside from this, we have the interest is compounded semi-annually or half-yearly or every 6 months. So, what does this mean? It means the balance of your debt or receivable grows, of course, by way of interest every 6 months. So, that's the meaning of compounded semi-annually. Now, let's see the twist because of this. So, what's the twist because of this in getting the present value of your debt? So let's answer that. So again, to get the present value, we have again the amount to be paid in the future times the present value factor. So substituting, we have 2 million times 1 plus I raised to the power of negative n, right? Again, we are using this 1 plus I raised to the power of negative n because you are to pay only once after 2 years. Okay? Now, the 1 plus interest will become 1.05 instead of 1.10. Why? Because of this semi-annually here. Okay? I mean, since 10% is for 1 year or 12 months, then the rate applicable for 6 months is only 5%. And we will be using that. And the n? The n instead of negative 2 for 2 years, we will now use negative 4 because there are 4 6 months in 2 years. Again, we are using 4 because there are 4 6 months in 2 years. So that's the effect of this compounded semi-annually. So in summary, if semi-annually, then the annual rate will be divided by 2, but the n will be times 2. Okay? So the compounding can also be made quarterly or every 3 months. So if that's the case, the annual rate will be divided by 4 and the n will be number of years times 4. And lastly, the compounding can also be done monthly. So the annual rate will be divided by 12 and the n will be the number of years times 12. So that's it for this video and the present value series. Before we end this video, let's put a smiley here. So, in the next video, let's go to accounting for loans payable already. So, if you learned, please click like, subscribe, and hit the notification bell to be updated on my next videos. So, thank you for watching and see you on the next one.